about here, where the zener starts acting up. Let me explain to you what's going to happen. Let's say that this is adjustable, okay? Which is what we're going to do in our lab today, or not today, this week. We're going to start off at 0 volts. Is 0 volts above 4.7 volts?
No.
No. That means that the zener is not going to, it's basically going to be open. And then I go 1 volt, 2 volts, 3 volts, 4 volts, 4.2, 4.5, 4.7. Up to that point, nothing is happening in the circuit. Zener is basically open. As soon as I go past 4.7 volts, let's say 4.8, 4.9 volts, then the zener will become active. It will which means that I've reached this point here. And at that point, there will be current which will start flowing. And the first current that you notice is this current here, which is called IZK. The K is for the knee. Okay? It's right at the knee. And so that's what this graph here is showing. It's showing this is not very accurate. We show it here in order to explain what the circuit looks like. But this knee is really a very tiny little current. Okay, just a few milliamps, 1 or 2 or 5 milliamps, and then you've got the maximum current. And then there is also called a current called the test current. So if you look at the third column, look at the third column in your spec sheet. It's called a test current, IZT. What is the test current for our zener? How much? Test current, third column.
For the 5230?
Current, Mohammed. 20 milliamps. Column 3. The first column is the zener, the second column is the zener voltage, and the third column is the test current. What is a test current? Supposing you're manufacturing these zener diodes, okay? So you're the company that's putting out these zener diodes, and so they're being manufactured. You come to the last stage where you want to now test that zener before it's shipped out to the customers. So there's a little test setup, and the zener comes there. It registers that it's good. So what do? They pass a current of 20 milliamps through that zener, to check to see if the zener is okay or not. So that's called the test current. So on the graph here, we can show a value here, IZT, 20 milliamps. So that zener is good for 20. If it's okay at 20 milliamps, then it is shipped out. Its maximum value is 97 milliamps. Okay, and we can operate it somewhere in this region where it's safe, around the test current, slightly above that, but not close to the maximum value. So those are the things we need to be aware of with the zener: is the maximum current and the test current and the voltage. One more parameter that's important is the power. So let's see if we can get to the power slide now. Okay. If I have a current of 48 milliamps and a voltage of 5.3 volts, what is the product of voltage and current? What is V times I? Power. So that can also tell us whether the zener is going to be safe or not. This zener, or this line of zeners, the power rating of the zener is shown on page 7 as the first important item. So go to page 7 now. And find power dissipation. Find the line called power dissipation under maximum ratings. Can you put a star beside power rating, power dissipation, P total? What is P total? How much?
500 milliwatts.
500 milliwatts. So, let's take my voltage and let's take my current in the Zener. Power is V times I. V is 4.7. I is 48 milliamps. What's 4.7 volts times 48 milliamps? 220 milliwatts. Write this down, guys. Write this down on that back page where I asked you to draw the circuit and I asked you to draw the graph. Do this calculation of power for this circuit. 4.7 volts times, no, milliamps times volts is milliwatts. Okay, so that's telling me that this Zener is good for 500 milliwatts. I have 220 milliwatts of heat produced at the Zener. Is the Zener safe? Yes, because it can handle 500 milliwatts. And I've only got 220 milliwatts produced at the Zener. Okay? So that's another important characteristic. So in this slide here, I showed the power 500 milliwatts. I show the Zener voltage, the test current, the maximum current. These are the most important values in a Zener spec sheet. So, what this is saying is that the Zener acts like a voltage supply. So in this circuit, I've got a 10 volt supply. I've got a circuit here. What happens is I start out at 0, I go up to 5 volts, and then let's say I go from 5 to 6, 7, 8, 9, 10. As this voltage is increasing, the voltage here stays constant around 4.7 volts. That means that the Zener is acting like a voltage source of about 4.7 volts. Okay? So that is how Zeners are used in a circuit, more like a voltage source. That's why Zener, another word for Zener or Zener circuit is a regulator circuit.